factoring. So we start off with factoring S, right? Here, which is kind of the backbone of everything else. Right? And we look at the box method grouping, we have 4 terms, right? And that was straightforward. We didn't have to do the X-ray thing. And we went down, we had 3 terms, which we learned how to turn into 4 terms by splitting them up into 2 specific numbers so that the grouping works. Right? Lastly, is what if we have only 2 terms? 4, 3, 2 terms. There's a couple ways of looking at it. The one, just think about, well, this is like, as if the middle number that's not there is 0. So you can do the exact same steps, just treat this like it was a 0 in the middle, and it works just the same. And that's the most straightforward way of looking at it. So you could go off and do the x and say what multiplies to negative 25p squared and adds to 0. Right. And that comes out to 5x and negative 5x. And since it's 0, you always notice that one's positive, one's negative. That's the only way, and it's the same number. That's the only way to get 0. It's the plus and minus of the same number, right? So we can go through here and say, well, that's plus 5x minus 5x. That's the 0 part. And then our minus 25. And do the same things we did on the warm-up. It's going to be identical. After that, we'll get, yeah, well, picking c's and p's, not x. Take out p here, plus 5. Here we can take out a negative 5. Both of these are negative, and you're left with a p plus 5 as well. So in the end, we have p plus 5 and a p less. So you'll notice this pattern when we have a missing middle term. It'll be a nice pattern to your final answer. Now, after doing enough of these, you're probably going to see a pattern that emerges. If you catch on to that pattern, by all means use it. But if not, please use this for now. So there is some other ways of looking at this. It might be a little faster, but I don't want to show you shortcuts and then it not make sense because then you kind of tend to use them in the wrong place and it makes more problems than it solves.
Can you do number 6?
A little bit. So let's get a few of these. You'll notice that here is r to the 4th. So what times itself will give you r to the 4th? It's a little bit different. So in your final answer, yeah, you'll know that you'll need r to the 2nd here. And to get that minus 4, you'll need a plus 2 and a minus 2. So just notice that they're not all to the 2nd power. Most of them up to this point have been to the 2nd power. And then your answer has always been x, x for p and p. So we could have r squared and r squared as well. We have those details. Now, we want to do this using the x, we say negative 4r to the 4th adds to 0r squared. And that's how you get negative 2r squared and r to the 2r squared. So you see the exponents are all a little bit higher. And then do the little work in between here. It always works, and some of you are catching on to this, especially with Khan Academy. Once you have your answer, it's check it. We'll play together. That's r to the 4th minus 2r squared plus 2r squared, that's 0, minus 4. And if it multiplies back together and equals the original problem, yeah, it's correct. It works every single time. Whether you do that 5 seconds of checking or not is up to you, but you can see the benefits, especially when you take your test on Wednesday. Before I turn it in, you can do that on every single problem and know your grade before you can. Now, like the warm-up problem, how you might have to check again, get here, and you have 5x plus 40, and a 5 comes out of both of those, you have to look to see if you can factor again and again. That's the same case with these as well. So we might get down to, say, number 15. See, okay, there's DCF 5, take that out. Now, what would p to the fourth minus 1 equal? Remember, like the one above, to get p to the fourth, we have to p to the second, p to the second. And to get negative 1, you have to have positive 1 and negative 1. Now, can either of those be factored more? And here's the main pattern if you haven't seen this yet. That how do you know these factor? Well, number one, they must be subtraction. Notice how all of them are actually subtraction. So there must be a difference. One Q. Next is, you notice the common relationship between these numbers. 25, 4, 16, 1, 9. Those are special kind of numbers. And that makes you see this so clear. I wrote those down like 1, 4, 9, 16, 25. What are these numbers? What's the special relations that they have? By what? They're what? They're squares, they're perfect squares. Yeah. 1 is equal to 1 squared, 4 is 2 squared, 3 squared, 4 squared, 5 squared. So that's not random, that's on purpose. So you can see how I'm quickly getting this answer here, p plus 5, p minus 5. That's because I can look at this and see, well, it's a difference of two things that are being squared. P squared minus 5 squared, so I know it's p plus 5, p minus 5. So you can use the 0x in the middle, and that'll work, and just do it like normal. But if you can recognize, well, it's two things that are being subtracted, so it's a difference of squares, they call that. If you want to look that up. The squares mean perfect square numbers. Right? That's these. You seeing those numbers, you know there's a pattern to your answer. You don't have to do quite as much.
Is it 4 squared 16 though?
Yeah, 4 squared is 16. That's 16. Yeah.
Oh,
Very nice.
I was doing it.
Yes. All right. So, looking at back to number 11, you can look at that and say, well, that's r to the second squared minus 2 squared. So, really, this problem is two things that are being squared and subtracted. So I know the answer is just going to be r squared plus 2 and r squared minus 2. It's always the same pattern of the answer. So you just have to be able to write it with 2 being squared with a subtraction on them. And you have to have both. If they're both squared but it's addition, it doesn't work. If only one squared is subtraction, it doesn't work. So two that won't work would be like r squared, so r minus 16 or something. So since this is not squared, it will not factor. That's fine. It doesn't do anything. Something like this, r squared plus 16. Well, these are both squares, r squared and 4 squared, addition, so that doesn't work either. So it has to be both a difference and 2 squares, difference of 2 squares. All right, so going back down here, you'll notice that, well, this, p squared minus 1 is the same as 1 squared. So that means that alone can be factored yet again. P and in one. It's going to be a P plus 1 and a P minus 1, right? And the rest of it stays exactly the same. So you have to do the factoring as many times as possible, not just one time and say, well, I took a 5 out, I factored, I'm done. Factoring is an ongoing process. You have to do as many times as possible, no matter what. Sometimes it's one time, this time it's 2, 3 times you have to factor it. Let's go all the way. Okay, so that's going to be the end of all the new methods of graphing, of factoring. So tomorrow is going to be all of them all mixed together, plus an activity. Monday is the same. Tuesday is a test review. Wednesday is a test. So we have a good 2-3 days of review of just let's get really good at this, and then you'll